Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome to Haseeb Electronics. Friends, in this video I am going to share with you SW2604 SMPS Controller. I draw this circuit by seeing this board. In the input side there is a fuse, then there is dual line filter, and unluckily there is no safety for high voltage, over voltage protection, anything, because it is the most cheapest design without any safety. Just only there is a fuse, inductor 9.8 microhenry, then we have bridge rectifier, then there is 22 microfarad 400 volt DC capacitor. This positive line is connected directly to transformer input side. The second line is connected to pin number 7 and 8 of this IC. This end, capacitor negative end, is connected to this ground line, and it is connected to this current sense resistor, current limiting resistor. Pin number 3 ground is for chip, for the control circuit. Pin number 4 is timing capacitor. Pin number 5 is feedback. Pin number 2 is VCC voltage. Here is 47 microfarad 50 volt capacitor. And pin number 7 and 8 are connected to transformer primary. And here is startup resistor. 1 mega ohm, 2 mega ohm resistor connected to pin number 1, and positive voltage, high voltage, 330 volt, 300 volt, whatsoever. What is the input? The voltage connected to pin number 1. So this IC, first of all, we have to see this IC, SW2604, cheapest flyback design IC, and it is used to 85 volt to 264 volt input at a wide range, and for power 8 to 12 volt, and it is used in DVD, TV tops, we can say satellite receivers, LCDs, monitors, printers. So it is pin out. Pin number 1 is OB, startup resistor. Pin number 2 is VCC. Pin number 3 is ground. CT, timing capacitor for frequency. Feedback, current sense. 7/8 is output collector. Design template, here are input filter, fuse, bridge rectifier, and here is snubber circuit, VCC winding, feedback network. Current sense is 0.75 ohm R3, so we can adjust current sense resistor. Pin number 3 is connected to ground, and pin number 4 is CT, so it's normal design. And in the output there is rectifier and inductor and like that, and here is TL431 and PC817 circuit for feedback. Block diagram of the controller. Pin number 7 and 8 are connected to transformer. Pin number 2 is VCC. Normally it is 4 volt to 9.5 volt. Normally around 6 volt is operating voltage. Pin number 6 is IS, current sense resistor. Pin number 3 is ground. Pin number 5 is feedback. Pin number 4 is CT, timing capacitor for oscillator. Feedback for error amplifier, for regulation. And here is the transformer core used in this design, that is EE19. It says for push-pull it is 25 watt, for forward converter it is 12 watt, and for flyback it is 6 watts. So friends, if any core you see the power handling chart, the rated power shown in that chart will be derated by 4. Here is 25 watt divided by 4, that means 6 watt in flyback. For forward half bridge it is 12 watt. For push pull it is 25 watt. When it will receive ground, it will take startup voltage, startup current. Pin number 4, there is a capacitor, so it should start switching. Pin number 4, 3, 6, when these components are connected, it should start switching. It will start switching. Pin number 7 and 8. So these pulses, how it will switch? It is working like a normal switch. If we see here, when we will turn on this switch, the lamp will turn on. The same, when it will turn on, the current will flow in the primary, so it will cause to induce magnetic field. Here we are generating light, here we are generating magnetic field. So this magnetic field will cause to transfer voltage in secondary and VCC winding or auxiliary winding. The pulse will pass from primary, it will cause to transfer voltage in the secondary. In secondary we have three windings. In secondary we have this one winding, second winding, third winding. Here is a diode, here is a diode, and here is a diode. If we see here, one diode, second diode, and third diode, we have three sets. This diode and this capacitor, this resistor. This bleeder resistor connected between diode output and ground. This capacitor, this diode have also bleeder resistor in parallel of this capacitor at this point. This point connected ground. Here is capacitor. Positive, ground. Positive, ground. So we will find voltage 15 volt output in front first section, 20 volt from second section, and 3.3 volt from this section. Meanwhile, there is a class Y capacitor here connected between the primary ground and secondary ground to compensate, to reduce the errors, to eliminate all the fluctuations, spikes, noises from secondary ground, and it will discharge in primary ground. Here we have TL431, two resistors are connected in series as a voltage divider network and connected to pin number 1. When it will reach at its required level, that time it will give a drive, it will give offset to pin number 2 of this optocoupler. Optocoupler pin number 1 is connected to through this resistor at this point. It will activate the window of this output transistor, and this transistor will conduct, and the ripples in the output level will be transferred through this varying light to the pin number 5. And there is a balancing resistor, 10K resistor in parallel of this capacitor, and these two components are connected across this optocoupler output side. It is one cycle of the frequency. So it is divided into time on, time off. At regular working, it have, for example, it have this switching level. When the output level will increase due to any reason, so at that time it will decrease its switch on time. First it was switching at this level, then it will decrease. It is variable. It will adjust, this IC will adjust at specific level what is required by this circuit, what is required in the output. So it will adjust this level. When the output level will decrease, so this IC will increase its duty cycle, this switch on time. Ground, it will keep switching like this lamp. As this circuit is working, the same, it will keep switch on, switch off, switch on, switch off between these two lines. This ground line will connect to this transformer, because transformer second end is connected to positive side, so it will cause to flow the current. When current will flow, it will cause to generate magnetic field in the primary. So this magnetic field will transferred in the secondary. So this is the total circuit design. Here is VCC winding. So VCC winding is providing voltage depending upon how much the conduction is being done here, how much the duty cycle is turning on and off this transformer. The same magnetic field will be translated in form of voltage and rectified and fed to pin number 2 of this IC. So this circuit, I have this time, when I connect to power, this circuit is short circuit. It turns on the lamp. If you have no good experience in power electronics, how to repair circuits, never do this. Never try to repair. So maybe this video will be informative. Here is a series lamp. So I am connecting it here. So this lamp is fully turned on. When you use series lamp, it protects too many things. If I will check AC, so it is dropping all the voltage. So that means there is a heavy short circuit in this circuit. I remove power. Now how to localize the short circuit? Always use isolation transformer and keep yourself isolated. There is something short circuit in this board, so we have to locate. How we locate? Set multimeter to continuity. First of all, check the input resistance at input terminals. That means the input circuit is safe. Set to ohms. So that means the bridge circuit is safe. It is giving 475 kilo ohms. So now set multimeter to diode mode. If we look at diagram, here is diode. When you test in the circuit, test the circuit in parts. No need to test every diode, just only if I connect this black lead at this cathode and connect this lead here, so this diode should read, and the second side this diode should read here, because I am testing this diode. And if I will connect this lead here, this diode should reverse bias. This diode should reverse bias. So I should not find continuity in this way. But if I will connect this side here, so that means this diode should give continuity and this diode should give continuity. And if I connect this line here, this diode is reverse bias at this line and this line. And if I connect here, so that means this diode must read continuity here, should diode drop voltage, and this line should drop voltage here. Let's test in the same way. I will connect black lead to positive terminal of the capacitor or cathodes of the diodes. So this capacitor is here, this positive terminal, and black lead at positive terminal. And check at the input terminal, it is showing continuity. How? As we discussed here, reverse the leads. It is 0.65, 0.65, 0.5, 0.5. This is the good way, that it is giving 0.7, and we connected black lead. We connected black lead here, red lead here. It is giving 0.5. So this is the good procedure. So at positive terminal of capacitor, this is good indication. But why we are taking this indication? That means there is something wrong in the circuit. Let's see the circuit. What is the possible reason here? What is the possible cause here? So possible cause here, if we see this positive side here, there is a resistor. So this is 1 mega ohm resistor. That means it should not give anything. And then there is snubber circuit. So here is 100k resistor. This resistor is 100k. For example, if this diode is short, we can say, but it is not logic because here is transformer winding, so this is not effective. Then we have another way. this line and this IC. In this circuit, it is possible that this IC is damaged. This IC can give a path. Otherwise, from this positive terminal, from this point, looking from this end, our one node is here, it is not effective, it is not effective, it is not effective. So there is just only this one reason that may be problematic, or might be this capacitor is short. If this capacitor is short, we can find the continuity here. We have to locate, we have to find. So I will remove this IC. I shall remove this IC. So I removed this IC now, and now we will repeat the same procedure. We will connect. Now we removed this path, which is possible path in the diagram. Now I connected this line here and it input terminal, so it is the good indication. That means it's now I will reverse the leads. I will reverse the leads, so it is open. In this way it's okay. It's okay. Now we have to check at second end of the capacitor, at the negative side. This is negative side of the capacitor. From negative side, it should give continuity here because it is now forward biased. Capacitor. And now I will reverse the leads. It should not give continuity. Black lead at negative terminal, so it give open. Suppose our one diode is short. Most of the time when there is a short circuit in the bridge rectifier, it burns or it becomes short in pairs. Now I will just only jumper one diode. And we will repeat the same test. For example, I bypassed this diode with a jumper. This line is good. This line is good. Okay. And now I will move this lead from positive terminal to negative terminal. This is open and this is short. It should not short. That means what happened? From this point to this point, this diode becomes short. When the diode becomes short, it will give continuity at the terminal. At positive terminal, black lead. This is good. This is good. I will move this lead here. So I should not find continuity like this point, but this terminal is giving continuity. So that means we have short circuit in the bridge rectifier. Now I will swap the leads. Red lead at positive terminal of the capacitor, it's open, it is open. Red lead at negative terminal, we are finding this one diode, but the second diode is giving short. So we have to locate which diode is coming in this path from this point to this point, so this diode is short. So we can determine the short circuit in this way. Now I removed this IC and I will connect power now, and we will see if the lamp is turning on or no. So here is input terminals. Always take care when you are connecting power, never touch the hot side. Now I connected. So now the lamp is silent, and we will see AC voltage. It is 233 volts, and we will check the DC voltage at this capacitor. Now it's okay, 332 volts. That's good. So that means our this IC was making short. Where is the short circuit? This ground is connected to pin number 4 through this capacitor. So capacitor is always open for DC. So that means this is not a possible cause. So we have direct connected to pin number 3, ground connected to pin number 3 and pin number 6. Set multimeter to continuity. So this is cut 1, 2, 3, 4, 5, 6, 7, 8. So 7, 8 true pins are connected to transformer, and pin number 6, this 6 number pin, 6, 7, 8, and here is pin number 3. We have to check continuity between 3 and 7, 7, 8, 6 and 7, 8. Pin number 6, 7, 6, pin number 3 and 7, 8 are open, and now pin number 6 and 8. It is giving 78 ohm. So 78 ohm at 300 plus volt, it is short circuit. So it should not give this indication. So that means our this IC is short circuit. It should open. So it should open. If it is giving short circuit, if it is giving this resistance, that means it is short. So when it is short, when we connect multimeter here, so it will give path from this side to the other point. So that was the reason it was giving indication at input terminals. So friends, I hope so this video is informative for you. If it is informative, hit the like button if you want. And if you want to watch my future videos, you can press the icon button. It is up to you. You have some suggestion, some comment, please let me know in the comment box. Thank you. Assalamu alaikum wa rahmatullahi wa barakatuh.